Welcome! Today we're exploring acid-base titration, a simple experiment that reveals how acids and bases interact. Imagine it as a puzzle where acids and bases fit together just right. Acids and bases are like two teams on a seesaw, each balancing the other. Acids, like lemon juice, taste sour. Bases, like baking soda, taste bitter. When they meet, they react to form salt and water, becoming neutral. Acid-base titration helps us discover the perfect balance between them. Let's meet our contenders for today. Hydrochloric acid, or HCl, a molecule that's famous for its powerful role in chemistry and even in our own bodies. And on the other side, we have sodium hydroxide, or NaOH, a strong base that's just as impressive and important in the world of science. HCl is our strong acid. Think of it as the tough stuff in your stomach that helps break down food, always ready to pack a punch and dissolve almost anything in its path. NaOH, on the other hand, is a strong base. You'll find it in things like drain cleaner, where it's used to cut through clogs and neutralize acids with its own powerful force. When these two chemical powerhouses finally meet, they react in a perfectly balanced way. This is shown in the classic chemical equation. HCl plus NaOH yields NaCl and H2O, a textbook example of neutralization. In simple terms, one molecule of HCl reacts with one molecule of NaOH to produce one molecule of NaCl. That's the table salt you sprinkle on your food, and one molecule of H2O, or good old water, the essential liquid that supports all life on Earth. Pretty cool, right? Together, they make a perfect match, a 1-to-1 ratio for a balanced reaction, showing just how elegant and precise chemistry can be. Now, that 1-to-1 ratio we just saw is key. It's like a secret code telling us exactly how much of each we need for perfect neutralization. In chemistry, we use this code, called the mole ratio, to figure out the unknown amounts of acids or bases. Think of a mole like a chemist's dozen. It represents a specific, enormous number of molecules. So when our reaction says 1-to-1, it means 1 mole of HCl perfectly neutralizes 1 mole of NaOH. Knowing this ratio is like having a superpower. It lets us calculate exactly how much NaOH we need to neutralize a certain amount of HCl, or vice versa. To unlock the secrets of the unknown solution, we need a trusty sidekick, the standard solution. This is a solution where we know exactly how many moles of our substance are dissolved in a specific volume. Let's say we have a 1 molar NaOH standard solution. This means we have 1 mole of NaOH dissolved in 1 liter of water. Easy peasy. If we only use 500 milliliters, or half a liter of our solution, we know we're using 0.5 moles of NaOH. See? With our standard solution, we've got the power of knowing exactly how many moles we're working with. Now for the grand finale. This is the moment where all our careful preparation and scientific curiosity come together for a big reveal. We're going to use our trusty standard solution and the reaction ratio to figure out how many moles are hiding in an unknown solution. This is a classic chemistry challenge, and it's where titration really shines. Let's say we have an unknown HCl solution. We don't know its concentration, but we do know we want to find out exactly how much acid is in there. We carefully add our NaOH standard solution drop by drop until we hit the perfect neutralization point. Oh, and we'll talk about how we know that another time. For now, just know that the color change tells us when the reaction is complete. Let's imagine we used exactly 250 milliliters, or 0.25 liters, of our 1 molar NaOH solution to neutralize the HCl. Measuring precisely is key to getting accurate results in titration. Using our molarity knowledge, we know we used 0.25 moles of NaOH. That's 0.25 liters times 1 mole per liter. This calculation is the heart of finding out how much reactant we actually used. Remember our 1-to-1 ratio? In this reaction, every mole of NaOH reacts with exactly 1 mole of HCl, making the math super straightforward. If we used 0.25 moles of NaOH, we know we neutralized exactly 0.25 moles of HCl. That means the unknown solution contained that exact amount of acid. That's the magic of titration. With just a bit of careful measuring and some chemistry know-how, we can reveal the secrets of any unknown solution. We've successfully figured out how many moles were in our unknown HCl solution. This is how chemists solve mysteries in the lab every day. turning the unknown into the known with a little science and a lot of curiosity. So there you have it, the basics of acid-base titration demystified. We learned how acids and bases react, how to use the reaction ratio to our advantage, and how to calculate moles in both standard and unknown solutions. High five for conquering chemistry.